Yellowstone is known for its boiling pools and powerful, unpredictable forces. But this year, something happened there that surprised everyone, from scientists to tourists alike.
Now to the extraordinary images tonight, the scare for visitors at Yellowstone National Park, the very close call with a geyser raining down rock and debris. Here's ABC's Mola Lengi.
This is the stunning moment a geyser in Yellowstone National Park exploded today.
Yellowstone National Park, a wild, boiling world of geysers, mineral terraces, and rainbow-tinted pools, is often seen as nature's ultimate showcase of beauty and unpredictability. It's a landscape born from fire and water, fueled by forces almost too vast to comprehend. But even for a place where change is almost a living thing, what happened this year caught everyone, scientists, rangers, and tourists, totally off guard. Imagine waking up to find the earth split open overnight. A deep, gaping hole where solid ground once stood, brimming with milky blue water that no one had ever seen. That's exactly what unfolded in the Porcelain Basin of Norris Geyser Basin, when Yellowstone's restless heart decided to make itself known once again. No warning, no seismic buildup, just a new pool appearing, strange, breathtaking, and more than a little unnerving, as if conjured from the depths. As word spread, alarm flickered nationwide. Was this Yellowstone's supervolcano beginning to stir? Was this the harbinger of more eruptions, or something worse? Today, we're plunging straight into this astonishing geological event, unraveling not only how this pool formed, but what it means for the park and for all of us. But that's just the tip of the geothermal iceberg. We'll uncover 20 of Yellowstone's most riveting discoveries, from ground-shaking tremors, shifting geyser patterns, and subterranean mysteries, to the supervolcano's hidden anatomy, a realm where scientific insight goes hand in hand with a primal sense of awe. Strap in, Yellowstone just rewrote the rulebook for You Had to Be There. Chapter 1. Overnight blue hole shocks Yellowstone. It wasn't an earthquake, and it wasn't a roaring geyser, just a cold, early morning in the Porcelain Basin subbasin, where some of America's sharpest geologists noticed something that seemed almost impossible. There, immediately west of a thicket known informally as the Tree Patch, yawned a brand new hole. About 13 feet wide, roughly circular, and filled with clouded, light blue water that seemed almost to glow under the wide northern sky. How could such a large hole just appear overnight? Was it Yellowstone's legendary supervolcano finally punching through? Here's the science behind the spectacle. Yellowstone's surface is a fragile crust, constantly bent and battered by invisible hydrothermal forces. Deep beneath, pressurized water and gas are always hunting for weaknesses above. Sometimes, when underground shifts weaken a section of ground, especially near hot, volatile regions like Norris Geyser Basin, a cavity collapses, creating what's known as a phreatic explosion. Suddenly, boiling water and steam blast upward, blowing out a hole and flooding it with hydrothermal spring water. Right now, the pool looks calm, but it is, in a sense, a scar, an ever-present reminder of the tremendous power hidden beneath our feet. The big question, was this the first step in a chain reaction, or is it simply the latest chapter in Yellowstone's ongoing story?
Chapter 2.
Was this the next supervolcano eruption? Whenever Yellowstone does something unexpected, fear of the infamous supervolcano spreads faster than boiling steam. And this new blue hole? It sent shockwaves of speculation across the country. The last caldera-forming Yellowstone eruption was more than 1,000 times the size of the 1980 Mount St. Helens eruption. The devastation, if anything like that happened in modern times, is hard to imagine. Could this newly torn open basin signal imminent disaster? Geologists rushed to the site, instruments in hand. Their verdict? For now, we're safe. The pool's dramatic formation, its eruption barely sprayed 3 feet high, a brief jet of muddy, mineralized water, was notable, but local and limited, not the start of an apocalypse. So why does the fear persist? Yellowstone's underground system is massive, and the possibility of a catastrophic eruption, however remote, exhales sharply looms large in public imagination. But experts stress phreatic explosions like this are local events, not triggers for massive eruptions. In fact, the odds of a true supervolcano event are extremely low at any given time. For now, small, rapid changes like holes and pools are reminders of the park's constant natural activity. Chapter 3. Seismic Sensors, Yellowstone's Silent Watchers. Within minutes of the pool's eruption, seismic and acoustic sensors stationed throughout the Norris Geyser Basin had already broadcasted real-time data, turning an unpredictable act into a carefully logged event. But how do these instruments read and record Yellowstone's every move? Seismic sensors detect vibrations from earthquakes, hydrothermal explosions, and even collapses beneath the surface. Acoustic sensors pick up sound frequencies caused by shifting water, gas, or rock underground. By combining this data, scientists spot patterns, rising tremor rates, subtle changes in underground pressure, or even the faint indicators of shifting hydrothermal fluids. With the blue hole, the instruments recorded a spike. Then things quieted again. No deeper tremors, no swelling pressure waves, no sign of something bigger. But that's what makes monitoring so important. Every event, large or small, becomes a piece of the puzzle for understanding Yellowstone's complex behaviors. Chapter 4. Geyser Basin Mysteries, Pools that Move. One morning, there's nothing. The next, a mesmerizing new pool. How do Yellowstone's ponds, holes, and geysers seem to appear or disappear with little warning? Beneath Yellowstone, a tangled network of pipes, fractures, and chambers snakes through the rock. When mineral-laden water carves a new shortcut, it can drain old pools or burst open new ones in moments. Sometimes these changes unfold gradually, but at times, a sudden collapse or pressure surge transforms the landscape overnight. In places like the Porcelain Basin, pools don't always stay put. Old pools vanish, new holes appear, and even vegetated patches near features like the tree patch face rapid changes. For tourists, every new pool is a spectacle. For scientists, it's another clue to the dynamic, ever-shifting crust above Yellowstone's hydrothermal systems. Chapter 5. Yellowstone's Unknown Depths, Supervolcano Secrets. Yellowstone's true anatomy is almost stranger than fiction. Under its scenic surface lies a vast, complex volcanic system, layered with ash, magma, fractured rock, and underground water. The current caldera, the volcanic depression seen today, formed after the last great eruption. But most changes in the park aren't signs of catastrophic eruptions. Instead, they're the result of the powerful, ever-active hydrothermal system. Pockets of gas, fragile pipes of minerals, and constantly moving water that can trigger collapses or sudden explosions. The new blue hole is a reminder that, while the big one is unlikely, the forces below are alive and unpredictable. What other surprises might still be hidden beneath Yellowstone's crust? Chapter 6. Porcelain Basin, nature's most active lab. Of all Yellowstone zones, the Porcelain Basin of Norris Geyser Basin is among the most volatile. Every inch is riddled with scalding water, acid, and volatile minerals. Why does this area seem to experience so much sudden change? Because Porcelain Basin sits above particularly active geothermal veins, the ground here is fragile. Even a small hydrothermal shift or cavity collapse can open a new pool, like the one recently discovered. The pool's milky blue water is a direct result of these extreme conditions, rich in silica, dissolved gases, and hydrothermal sediments stirred up by sudden changes or collapses. It's a place of constant, visually stunning transformation, with every new feature another testament to ongoing geologic activity. Chapter 7. Tree Patch. Survivors, when vegetation meets fury. Near the new blue hole stands the tree patch, a cluster of vegetation that somehow clings to life right next to boiling pools. How do plants survive in such a hostile environment? The vegetation exists because of slightly cooler ground, shallower water, and fewer minerals in that precise spot, at least for now. When the ground nearby split and the new hole appeared, botanists rushed to observe which plants survived and which succumbed to the sudden change. Living so close to volatile hydrothermal features means these plants are constantly adapting or giving way. Every major shift in the basin trims back the tree patch's survivors, keeping the boundary between life and destruction razor thin. Chapter 8. Echoes from below. Muddy eruptions recorded. It was the seismic and acoustic sensors that gave the best account of the blue hole's birth, recording the eruption's muddy burst, bubbling roar, and the hiss of water meeting the air. Seismographs pick up tremors caused by the eruption, and acoustic sensors record the bubbles and shifting rocks. These help scientists determine the cause, whether it's steam-driven, ground collapse, or a combination of factors. Though the event was modest, just a 3-foot spray, it left data that adds to our understanding of how and why the ground can rupture so suddenly. Chapter 9. The Fear Factor. Public reaction to Yellowstone's surprises. When the story of Yellowstone's sudden blue hole hit the news, a wave of concern swept through the public. Was disaster imminent? Would an enormous eruption soon follow? Yellowstone's supervolcano reputation looms large, fueled by its ancient history of massive eruptions. But scientists on site stress that minor hydrothermal events, like this one, are not harbingers of major eruptions. Rather, they are normal, if dramatic, signs of constant, ongoing geothermal processes. While public fear is understandable, it is often misplaced. As long as experts closely monitor the park, the risk of sudden, catastrophic eruption remains extremely small. Chapter 10. Black Diamond Pool. Surprise, when pools rage before dawn. Just over a year ago, visitors to Yellowstone's Black Diamond Pool witnessed a spontaneous event. A sudden eruption of steam, mud, and water captured on early morning cameras. Are all Yellowstone's pools ticking time bombs, waiting for a dramatic moment? Many pools, like Black Diamond, have dynamic underground plumbing. Pressure can build up behind constrictions in the subsurface piping, and a sudden release, sometimes unaided by any earthquake, can lead to dramatic but local outbursts. Such surprises may be more likely early in the day, when overnight cooling has changed the balance of pressures. Chapter 11. Mineral layers reveal geothermal activity. Beneath every new pooled surface is a story written in minerals. These freshly exposed layers, silica, sulfur, calcium carbonate, are deposited over years by hydrothermal fluids. The blue color in the new pool comes from suspended silica particles that scatter light. Studying these minerals gives scientists clues about when vents were active, what kind of hydrothermal fluids were involved, and how the underground environment has changed. Each new hole is another page in Yellowstone's continually unfolding geological diary. Chapter 12. The Great Yellowstone Eruption. Unthinkable Power. The word supervolcano invites speculation. Past Yellowstone eruptions massively outscaled events like Mount St. Helens. But could a local hydrothermal explosion, like the new blue hole, ever trigger a supervolcano eruption? Experts say that's extremely unlikely. A true super eruption would be accompanied by persistent, large-scale warning signs. Significant earthquake swarms, rapid ground swelling, widespread changes in surface chemistry, not just the appearance of a single new pool. Hydrothermal events, though dramatic at the surface, don't indicate magma is on the move. Still, they are reminders that Yellowstone is shaped by forces beyond our usual sense of scale or control.
Chapter 13. Superheated plumbing, Yellowstone's volcanic engine.
At the heart of every geyser, mud pot, and hot pool is Yellowstone's hidden hydrothermal plumbing, an intricate labyrinth of fractures and conduits connecting deep heat with the surface. Hot magma below the park heats groundwater. Superheated water and gases rise, sometimes blocked by mineral buildup or shifts in the rock above. Enough pressure and the system can push through, creating new features like the blue hole in seconds. Even minor underground shifts can reroute entire networks of fluids, drain old pools, or create explosive events overnight, demonstrating just how alive and dynamic Yellowstone's underground world really is.
Chapter 14.
Norris Geyser Basin, Earth's loudest laboratory. Norris Geyser Basin, home to the new Blue Hole, is famous for hosting Yellowstone's hottest, most acidic, and most changeable features. Why is this area so hyperactive? Norris sits where major geologic faults intersect, acting as a vent for enormous underground pressures. The result is unpredictable. Frequent steam vents, surprise eruptions, and lately, sudden holes. It's so chemically active that neither water, land, nor even color can be relied upon to last long. Scientists closely monitor Norris, using every new change to refine their understanding of Yellowstone's risks and resilience.
Chapter 15.
Earthquake swarms, Yellowstone's subtle tremors. Underneath Yellowstone, small earthquakes and tremors are constantly being recorded. Hundreds per month, most too small to feel. Do these earthquake swarms mean a big eruption is coming? In most cases, they're a sign of normal activity, shifting magma, water moving through cracks, or the crust flexing. Occasionally, clusters of tremors coincide with surface changes, like new hot springs or pools, but they rarely signal immediate danger. Instead, every swarm helps scientists map out the complex web of Yellowstone's faults and hydrothermal systems, watching for any pattern that breaks from the norm.
Chapter 16. Chemical wonders, milky blue water's secret.
The color of a Yellowstone pool can tell a story. So why does water sometimes glow milky blue and other times run clear or orange? Milky blue arises from a mix of fine silica particles suspended in superheated water. When surface crust collapses and new underground fluids rush up, sunlight scatters off these tiny particles, creating that signature blue. Over time, chemical changes or changes in water flow can shift the color again. Samples taken from new pools help geologists track which reactions have dominated and give clues about changes in Yellowstone's underground chemistry.
Chapter 17.
Eruption anatomy, the 3-foot burst. Though the new pool's eruption was only 3 feet high, it was enough to make a lasting mark in the landscape. What does a small burst like this reveal about the forces at work? Even a modest explosion can move significant quantities of sediment, create new vents, and rearrange existing features. It shows how local increases in pressure or collapses underground can reshape Yellowstone in a matter of hours. Each event, no matter how small, helps scientists understand baseline activity levels and the scale of change that can occur at a moment's notice.
Chapter 18.
How scientists predict the unpredictable. Tracking every geyser, shifting pool, and tremor in Yellowstone is an ongoing task. Scientists watch for patterns in seismic activity, gas emissions, ground deformation, and surface temperature. Can we truly forecast these sudden events? Not precisely, But with each data point, scientists improve their models and their ability to respond quickly. When indicators like heat, tremors, and gas spikes line up at the same location, a new hydrothermal event could be imminent. If the system goes quiet, it usually means a lull has set in. Advances in remote sensing and even machine learning are helping forecast risk areas more clearly than ever before, though Yellowstone always keeps some of its secrets. Chapter 19. Why every hole matters. Lessons from change. Visitors to Yellowstone may see new pools as photo ops, but to geologists, each hydrothermal event is a chance to learn. Each new hole maps the weak spots in the landscape, highlights changes in underground plumbing, and gives vital information about ground stability, chemistry, and hot water flow. These small events provide test cases for models and hazard maps, helping refine our responses to true emergencies. Yellowstone's frequent, relatively minor fluctuations give an invaluable laboratory for understanding how dynamic Earth systems work. Chapter 20. The night Yellowstone changed again. The new pool in Norris Geyser Basin stands as a reminder. In Yellowstone, the extraordinary is part of the routine. Beneath each overnight burst and boiling spring, there's a story of energy, heat, and transformation. Scientists remain constantly alert, monitoring even the smallest changes. The Porcelain Basin's latest scar urges us to look deeper, remember the untamable forces beneath the park, and respect the unpredictability of the planet itself. Yellowstone's next surprise may already be building, visible only to the watchful sensors or the keen eye of a visiting geologist. No one knows exactly what's coming, but we do know this: change at Yellowstone never stops. Until next time, keep your curiosity as wide and enduring as the Earth itself. And remember, beneath your feet, the world is always changing.